Years in development, this Man-O-War UAS prototype proof of concept airframe is here and being made ready for sea trials. The Man-O-War Unmanned Aircraft System, UAS, is flying and performing as expected. This sophisticated airframe is leading the way in the development of drone technology. The current practice in the tuna industry is in the use of helicopters to locate tuna. The cost and danger of this age-old system is now ready to be replaced by the new, efficient Man-O-War UAS system. The purpose of the Man-O-War is to increase the production and reduce the cost of harvesting tuna while totally eliminating the danger to human life. The Man-O-War is an efficient, safe, cost-effective system that allows the leaders in the industry to take advantage of the latest in technology. Drone Surveillance International Corporation, DSIC, has partnered with Right Wing, an award-winning Arizona UAS design and manufacturing facility, to create, fine-tune, and produce the proven design of this prototype of the Man-O-War UAS system. Kansas University has presented our partner Right Wing one of the first FAA-type accepted applications. This means that our UAS, the Man-O-War, with its proven technology, rugged durability, and ease of use, will be the first UAS in the world to be FAA type accepted. Kansas University is underwriting this application. The Man-O-War UAS system is made possible with the maturation of several high-tech, diverse systems. Sophisticated avionics flight control systems.
Your airspeed, altitude is always great to know. Your artificial horizon is pretty cool. You can see the attitude of the plane. These are all your flight controls, just for simple, straightforward. If you want to change altitude, airspeed, or radius of a loiter, they're just sliders.
Lightweight telemetry systems.
Long-range radio system. Your receiver, antenna for this receiver.
For that receiver.
Next is you have your telemetry radio modem for the ground station. It's mounted right on top of the Ruby here. The antenna runs out. That would be the antenna on the far end.
Long-range virtual cockpit flight FPS video.
Video gear composes your cameras, which are on your pan and tilt mechanism, and the antenna for this.
GPS.
We'll have it written into where you can click on a GPS point, or you can actually click on something and have recognition software, and once it sees that, it'll follow it, and no matter what, the plane itself will end up having the camera pointed on it.
Digital imaging systems.
Yeah, I do too.
See if we can get it.
Lyle, this picture is very good. That green line right there shows exactly the
Direction of travel.
Worldwide Google streaming maps.
That's east.
Tell me on here.
Oh, this way. Straight out.
Straight out like there?
Yeah.
Right there's the palm. Here's the palm trees then, right?
Yes.
I would like to set the waypoint right there. I'd like to have it go out right here.
Yeah. There you go.
Do I want to come back to here?
Yeah, you can go there and then start flying out that way a little bit.
How about right here?
Pan and zoom remote cameras.
Your pan and tilt are these two knobs right here.
And it's also stabilized the camera, so when the plane's rocking, the camera's trying to stay stabilized right into that zone of where it's loitering.
Pan and tilt.
You'll be able to see that right on the television or camera monitor or whatever with that, where you can move it around.
High durable energy dissipating construction materials.
This is a very durable aircraft. It'll take some blunt force trauma. It's made out of a material called EPP. It's called expanded polypropylene. It is a closed cell foam. It's steam expanded and pressed. It takes impacts very well and comes back with no dents, no major issues to it. The airplane that's made out of this and filled with its reinforcement spars, being a carbon fiber main spars and a fiberglass strip spar in the main wings. This airplane will take blunt force trauma on impacts.
Autonomous flight controller.
This is the little triangle here represents the airplane. The little lines that you see kind of flickering around are indications of the airspeed and your relative heading. That's why they're changing all the time. The little trail you see here is the path that the plane has flown so far. Up in this corner here, you're showing the condition the plane is set in on Ruby. Right now it's loitering at that position. You can see it's just doing a circle over and over and over again right there. It's indicating that the handheld has got control of the plane right now. It's also showing that right up here. Right here it shows handheld operator in control. And then these are all your flight controls, just like you'd see in a real airplane. It's completely configurable.
Ground control station.
That's great. That's exactly what we want.
Yeah.
30 knots.
Yeah, that's us right there. And let's bring it down.
We have it.
So
We're moving straight on out.
To hand this off, 4 clicks. It's in the loiter.
It's in the loiter.
So now you can just right mouse click. Yeah, it should come out to our field and start loitering again.
It's coming back now.
You've got it set. It's going way back.
I'm loitering.
Zoom out the map a little bit.
Right here?
Yeah.
Autonomous spot landings.
Keep your eye
It's coming in.
coming in.
It's coming in.
And it's going to be, keep your eye on it. It's going to be good. You're good to go. Nothing's going to go wrong.
Nothing. Perfect. Perfect.
Bingo. Gotta love that, huh? Is that cool?
You landed better than I did.
I know, it landed on the mark.
Waterproof high-density battery pack systems.
Simple. What's nice too is when you're using it, you have the flip up
Oh, I
springs.
like that. That's nice, yeah.
So when you got it on the table, it's much easier to use. And then these will also do up to 12S. Great for airplane use if you need to travel and do demos.
Waterproof support systems.
There's an integral waterproof seal. It's an O-ring seal that goes all the way around the perimeter of this box. This box is a military grade waterproof box, and it will be completely sealed. You could drop it in the ocean and it can float for months without any water getting into it. And this would be something that every boat that these go on this would be for charging systems.
The DSIC Man-O-War system has a range of approximately 100 miles, 50 miles out and back. Can fly for approximately 2 hours on each mission, depending on wind and weather conditions. Can operate from 20 to 70 knots with a cruising speed of 35 to 40 knots and normally operates at an altitude from 50 to 300 meters, but has a ceiling of 3,000 plus meters. It has fail-safe systems that allow it to return to the ship in case of low batteries or other malfunction.
The return to home and loiter automatically is set for 400.
The Man-O-War can land in water, send out a locating beacon, and float until picked up without any saltwater damage to any delicate electronic components.
It's waterproof. It could be floating in the ocean, and it will not absorb any of the water, and it won't damage it at all.
The airframe has a wingspan of 5.8 feet and can carry a payload of up to 12 pounds, all powered by an efficient 6,000 RPM high-power brushless electric motor.
It has 1,100 square inches of wing area and 12-inch less wingspan. So we're trying to make more of a purpose-based, robust aircraft that's really going to be focused into what we're trying to achieve here.
The Man-O-War is the highest lift and most rugged airframe for any unmanned system in its size class.
Go back that direction, and then these are totally countering it the other direction.
The Uther Ruby Autopilot is a virtual cockpit and operates all systems and integrates all flight sensors, communications, and payload interfaces into a neat, elegant package.
The Ruby itself is all contained here. It's a little bit bigger than a domino, and this is where everything happens. This is where your telemetry is plugged into. All your receiver is plugged directly into this. Everything comes to Ruby for complete control.
The on-point onboard display is controllable through the autopilot. No separate applications are required. The flight system is very simple to operate. Most features are automatic once initiated.
You got some wind up there. Yeah, you did. What it's doing is, because the wind is blowing so strong up there,
Right.
the loiter has switched from a circle to a pace.
Pace.
So what it's doing, it keeps pacing back and forth through the new loiter spot. It does that automatically.
What does the red mean on the altitude?
That we're over 400.
Oh, okay.
Move the map. Click and drag.
Yeah, you can do that. You can see
How long have we been out?
we're pulling 13 amps.
Wow, that's good.
And worldwide streaming Google Maps are integrated in the system.
Yeah, I just wanted to bring it home because we were looking at the altitude and we were concerned, but it actually seems fine. Everything seems fine. Where are we on juice?
Yeah, what do you, I was just going to ask, where are you?
Launch and touch a button to start an automatic loiter. The drone then flies a circle pattern waiting for further instructions.
Lines that you see kind of flickering around are indications of your relative heading. That's what they're changing all the time. The little trail you see here is the path that the plane has flown so far. Set in on Ruby, right now it's loitering at that position. You see it just doing a circle over and over and over again right there. As they flip the switch, you'll see that change. Laptop.
Just enter the GPS point of the birds, and the man-o-war autonomously flies there and loiters over the tuna.
It's what it does until we tell it to do something else. So let's say we want to fly here. Yep, I'm doing that. Okay. Once you see your green, it's locked to that point, and there goes the plane. I'm going to move it over here a little bit, right mouse click. Target position here. Target position. There we go. Let's move it out there. Get it away from the building.
I think you hit
So
the
it
wrong
was-
thing again.
It's gonna
No, it's doing it.
Oh,
it's gonna
really?
go to that red dot, right?
Yep. Right now we're at 400 feet. I'm going to bring it down just a little bit. Yeah, it'll always loiter when it gets to the new spot.
When it hits the waypoint, it loiters.
Sending back a live video image of what is there while it notifies the operator. The operator can then hit one button and the UAS awaits further instructions or returns to the ship.
You get it?
Okay, right now what it's doing is it's automatically doing a return to home and loiter. It's waiting for me to take it. I'm going to say, okay, laptop. We have it. It's what it does until we tell it to do something else.
There you go. Yeah. Now go ahead and cut the power. And glide her in and let it sink. Just let it sink. And even if it goes past you, that's fine. Just let it sink. Let it get as slow as possible. They're beautiful. The thing lands like butter. It's an easy plane to fly. Fly it like a cream puff.
It can be launched with a small onboard launcher or by hand and is recovered by landing in a net or in the sea. System specifications. The system is specifically designed for the tuna fleets of the world and includes 2 man-o-war aircraft, 1 ground station, a full complement of spare parts, support equipment, flight and maintenance training. The Drone Surveillance International Corporation's man-o-war UAS is the only system whose sole purpose is to find and spot tuna. For further information, contact Drone Surveillance International Corporation.